Okay, so welcome to Advanced Engineering Mathematics. So the subject code for Advanced Engineering Mathematics is ECE 221. This will be one of your subjects for the second semester. So for the prelim discussion, we will be talking about complex numbers. And among the topics we have to discuss are the following. So we have to know the basic of the theorems of complex numbers. We need to understand what is a complex number at the same time. So we have also to know the different forms of complex numbers and try to convert different forms of complex numbers to another. So also we will be having solving of a lot of problems concerning complex numbers. So among sa mga kinanglan natin i-solve is the addition and subtraction of complex numbers. We also have multiplication, division, and also the roots of complex numbers. Also, we have the powers of complex numbers. So as part of this, what is expected of you is that you should be able to evaluate the theorems on complex numbers. At the same time, you should be able to solve problems about complex numbers. Okay, let's start. Complex numbers problem, medyo ano na kamo, medyo nabalaan nyo na kung anong complex numbers. So, complex number is a combination of a real and imaginary number. The square root of a negative number is called as imaginary number, where the imaginary unit denoted as J, sa iban ginagamit natin is I, but for the advanced engineering mathematics, we will be using letter J to represent an imaginary number. Imaginary unit denoted as J satisfying the relation square root of -1. So I will be, if you would like to know about the history or the topics about the imaginary number, I will be posting isa ka article about the imaginary number. You can check na sa either sa website or sa site nga naton or pwede man nga makita ninyo sa inyo Google Classroom. So, uh, let's make this first a overview gid sang advanced engineering mathematics. If you would like to know about advanced engineering mathematics gid in details, so amo na siya ang kinahanglan naton understand ang complex numbers gid danay. So if I'll go back sa experience ko sa board exam, advanced engineering mathematics is one of the subject gid nga damo-damo sang nagwa, especially if sa latter part na discussion ng sining subject which is about Laplace and inverse Laplace transforms. So medyo ara siya sa importante nga part especially in mathematics. So if we will be talking about mga budlay, yung mga subjects in mathematics, it would be kabalo na mga bagita din. We have calculus, we have either integral, differential equations. But inaama siya nga mga subjects, mga mathematics subjects. Hapos lang na siya sa kung sa board exam because they can be manipulated through sang calculators. So may ara shortcuts kung paano siya kuhaon sa calculators ang mga differential or mga calculus nga problems. So ang natabo sa board exam, ang ginhimo nila is they focused more on the advanced engineering mathematics ng mga topics. So kay kalabanan diri. So hindi siya ma-solve using sang calculator. So amo na yung ginabutang nila sa board exam. So let's have a short lang historical timeline of what of the complex numbers or historical timeline about sa mga taho or mga butang pwede natin ma-encounter diri sa advanced engineering mathematics. So Euler was a very influential in the standardization of other mathematical terms and notations. He named the square root of -1 or -1 with the symbol I. So But the Risaton, we are representing it with J. The most important mathematician of the 18th century was Euler, who in addition to work in a wide range of mathematical areas, was to invent two new branches. So isa si Euler sa nag uh, sa may dako ang contribution in the calculus of variations and differential geometry. So Euler was also important in pushing forward the research in number theory begun so effectively by Fermat. Throughout the 19th century, mathematics became increasingly abstract. In this century lived one of the greatest mathematicians of all time, which is Carl Friedrich Gauss. Leaving aside his many contributions to science, in pure mathematics, he did revolutionary work on functions of complex variables. In geometry and on the convergence of series, we have the first satisfactory proofs of the fundamental theorem of algebra and quadratic reciprocity law. So, kung tan-awon ta lang man gid sa sini nga timeline, ang may ara lang gid nga very nga part is Carl Friedrich Gauss kag syempre si Euler. So, we have to continue with the what knowing about sa complex numbers. We know na J is square root of negative 1. So, we will have a to discuss about the successive integral powers of J. We will have this one. So, okay, J, syempre J is equal to J. So, kung tanawan naton, so we will have J is equal to J. Okay, ari siya. Next, J is negative 1. So, square root of negative 1, kung i-squared mo siya, then we will have J cube. So that is, kung i-factor out natin ang cube sa baba, ang mabilin is J squared minus J multiplied by J. So J squared is equals to negative 1. So that will be negative J. Next, J to the fourth. That is J squared. Squared mo pagod siya. So that is negative 1 squared. Positive 1. Okay, if we continue to increase the values ng iyang power, we will have J to the 5. Okay, so anong matabo sa J to the 5? Factor mo siya by J raised to the power of 4. Okay, we will have this one, J raised to the power of 4 kag multiplied mo by J. We also have J 6, J to the 4th minus J squared. For J 7, J to the 4th minus J cubed. So take note that we are trying to factor with, ginapagwa na lang na yung 4. Because we know nga ang J raised to the power of 4 will be equal to 1. So, ma-1 ano siya dahil. So, ang mabilin is same lang sa chat 1. If you would inspect sa ato yung mga answers, the rate sa ato nga ginikuha subong. Successive integral powers of J, sulit-sulit lang siya. Halin sa imong value, halin sa J. So, we have may ara ka values ng J sa babaw. So, we have kay may ara kita J, may ara kita negative 1, then negative J, and 1. So, if padakuon pa natin ang powers ng aton nga imaginary number, same lang siya po, masulit-sulit lang siya gali. So, we have J, we have negative 1, we have negative J, and we have positive 1. So, we can then conclude using isang sininga theorems, we could have a general formula kung ano ang matabo. So, general formula, so we will have, kung pwede natin himuon, 1 is equal to J. So, take note lang na factor out mo lang siya by 4 yung kada permi. Then, kung yung imong remainder is 1, ang answer nimo is J. So, next, ang imong J raised to 4n plus 2. Kung ang imo naman nga remainder, sang i-divide mo ang imong exponent by 4, if your remainder is positive or is 2, then ang imong answer will be negative 1. Next, we have J is equals to J, kung 3 naman ang imong remainder, will have negative J. How about J for n? Kung 4 naman siya, for imong remainder sa automatic, that will be equivalent to 1 na sa So, medyo sulit lang na siya. So, pwede man natin gamiton ang ating calculator to solve for sa mga among nga problems. Kaya medyo hapos pa na siya. If we would like to use our calculators, okay lang. Kaya medyo pwede pa ni magamitan natin sa calculator. Next, we will have theorems on complex numbers. So may ara kita tatlo ka theorem nga kinahanglan mabalaan in terms of complex numbers. So based diri sa aton nga module, may ara kita di ginplastar ko na daan. We have tatlo ka theorems of complex numbers. First, if x plus jy is equals to 0, then x is equals to 0. Okay, take note, x is equals to 0 and y is equals to 0. So, paano natabo? If we are going to deal with the complex numbers, so may ara kita duwa ka part. We have the real part and we have the imaginary part. So, ano ang real part dari sa aton nga equation? So, real part natin will be x and our imaginary part will be the jy. Okay, since ang aton nga right side of the equation is equals to 0, so wala ka imaginary part, wala ka man real part nga na-specify gid. So, ang matabo, you are going to equate sa aton nga left side to 0. So then, x natin will be automatically be equal to 0 and y will be equal to 0. Next, we have another nga theorem. Karon ta lang tingbon ta lang ang pagplastar sang example for the theorems of complex numbers. So medyo related lang man ni sila nga tatlo, but we have theorem number 2. If x sub 1 plus jy1 is equals to x2 plus jy2, then x1 is equal to x2 and y1 is equal to y2. So take note lang ang aton nga real number is x sub 1 sa left, x sub 2 sa right. Then jy1 and jy2. So ang matabo, equate mo lang ang tanan nga real numbers and then equate mo man ang imaginary numbers. So x sub 1 is equals to x sub 2, y sub 1 is equal to y sub 2. Same naman siya po ng aton nga theorem number 3, I mean. So will be parehas lang sa aton nga theorem number 1. So equate mo lang by 0. Okay, so we will have to deal with the examples nga presented diri sa libro and we will try to solve karon sa problems nga wala ni plastar dara sa inyong module. So, example number 1. This is really simple. Find the real values of x and y in the equation. 2x plus j 4y minus 3 is equals to j 3x minus y minus j 10. So, if we are going to trace ba or to balikan nato ang theorem naton kagina, which is theorem number 1, so we have to equate sa aton same man Japon with theorem number 1, either theorem number 2, same lang man Japon ang kinahambal nila. So you have to equate the imaginary part to imaginary part, real part to real part. So ang matabo, we have to equate the real part. So ano ang real part naton sa aton nga problem or sa aton nga equation? Real part naton is 2x minus 3 then minus y. So if we are going to equate it to 0, para ma-simplify siya, salinin natin ang negative y. So ang matabo, we have 2x plus y minus 3 is equal to 0. Next, ang ato naman nga, and that will be our equation number 1. Tamo na siya nga equation number 1. Next, we have to treat naman sang imaginary part ng ato yung equation. So, we have 4y is your imaginary part. 3x is also imaginary part. So, then we have negative 10 as your imaginary part. If we are going to equate this equation into 0, so we will have sa aton nga equation which is negative 3x plus 4y plus 10 is equal to 0. So, hindi ko na siya pagdetalya kung paano nakuha nato ng value of x and y. So, kabalo na ka muna, we can automatically compute it using some equation sa calculators. And if we are going to manipulate it using mathematical or algebraic operations, we will find out that x is equals to 2 and y is equal to negative 1. So, wala ko na din plus star ha nga dapat isa-isahon kinaton kay that part is an algebra na nga part. It does not hindi na dapat naton i-cover sang nga isa-isahon pa there is advanced engineering mathematics because we are not tasked to solve pa about the algebra. So, pwede na kung may alang-alang ka pa sa algebra or medyo hindi ka pa da sagad-sagad, so pwede natin balikan ang algebra. At the same time, pwede natin balikan ang aton nga trigonometry nga topics. So, another example. Solve for the angles theta and in the following, we have cosine squared theta plus sine squared theta minus j cosine. Ano na siya galing symbol? Alpha na siya. So, is equal to 0. We have cosine squared theta minus sine squared theta plus j cosine squared. So, anong matabo diri? Based on theorem number 1, we have to equate it to 0. Kay 0 ang ato nga right side of the equation. So, ano diri nga part ang aton nga imaginary kay ano diri ang aton nga real part. So, our real part is ang wala upod nga j. So, that is cosine squared minus sine squared theta. So, mangita kita diri sang mas medyo okay nga color. So, we have okay, for aton nga imaginary nga part, okay, para sa aton nga imaginary nga part, that would be j cosine squared. Okay? Alpha, or I'm not sure some Greek na letter. Then we will have, equate natin to 0 ang ating nga cosine squared. That will be cosine squared is equals to 0. Then, cosine, if we are going to square root both sides of the equation, we will have cosine is equal to 0. Then, finding the value of the angle that will be, so our cosine lang sang 0. So that means that our angle will be equivalent to 90 degrees. Okay, nakuha na natin ng isa ka angle. So now, our task is to find the value of the angle theta. So we have, based sa aton nga problem that our real part is cosine squared theta plus sine squared theta is equal to 1. Then cosine 2, this, if we are going to go back sa aton nga trigonometry, so this is the reason nga again pa-review taka mo sa inyo nga trigonometric identities and trigonometry nga topics because we are going to use that identities in finding sa mga in substituting sa mga values dali sa advanced engineering mathematics. If we are going to convert it into sa isa lang ka term, this is a double angle nga identity. So, double angle identities, we will have cosine squared theta plus sine squared theta is equal to cosine 2 theta. So, ang matabo, we have cosine 2 theta will be equivalent to the arc cosine of 0. Then, we have the arc cosine of 0 will be 90 degrees. Then, by mathematical operations or manipulation, we will find out that theta is equal to 45 degrees. So now, another example, we have solve for the angles theta and alpha of the following. So we have cosine to the fourth theta minus sine to the fourth theta plus j cos second squared theta minus 1 is equal to 0. So, same lang man Japon. But, ang kinanglan natin himuon is to dapat is to deal or equate sa aton nga real part to real part or imaginary part to imaginary part of the equation. However, ang aton nga right side of the equation is equal to 0. So, tracing back or going back sa aton nga theorem number 1. So, we are going to equate sa aton nga duwa ka part, the real and imaginary parts ng equation into 0. So, ang matabo, we have cosine to the fourth 2 theta minus sine to the fourth theta plus j cosecant squared minus 1 is equal to 0. So we'll have, so take note of the characteristic sa aton nga real part. So we have, this is a perfect square binomial. So we'll have, so kung convert ng perfect square binomial, so we'll have a squared minus b squared, for example. So you will have, okay, for example, may ara ka equation nga a squared minus b squared. So, amo nang given sa imong equation. Or try to factor this out. We will have, so there is sa piyak, we will have a minus b. Then sa piyak, we will have a plus b. So, amo na siyang natabo sa sininga solution. We will have cosine squared 2 theta minus sine squared 2 theta. Then multiplied mo by cosine squared 2 theta plus sine squared 2 theta. So, para mas maintindihan, we will have, for example, you have a to the fourth minus b to the fourth. Then, kung mag-factor ka, we'll have a squared minus b squared multiplied by a squared plus b squared. So, take note nga, amo lang na siyang ginhimo naton. But, ang lain dira because we are using trigonometric na mga functions. So, we'll have cosine and at the same time, ang ating angle dira is 2 theta. So take note also that by trigonometric identities, cosine squared plus sine squared will be equivalent to 1. So automatic, this 1 will be equivalent to 1. Cancel out na natin. So ang mabili na lang is we have cosine squared 2 theta, sine squared 2 theta will be equal to 0. Okay. Now, balikan naman natin liwat. We have cosine squared 2 theta minus sine squared 2 theta. Inhatag ko sa inyong assignment is to study some trigonometric identities. This one is also a double angle identity. So cosine theta, cosine squared minus sine squared is a double angle identity which is equivalent to cosine 4 theta. So kung ang nakabutang diri dapat is cosine, so cosine squared minus sine squared theta. Example, amo na ang nakabutang sa imong angle or sa aton nga equation. So kung i-convert ni sa naton into sa iya nga double angle nga equivalent, this will be equivalent to cosine 2 theta. Kung amo ni ang given. However, tan-aw naton ang given naton is 2 theta na nga daan. So we have to substitute dari 2. So dugangan naton 2 ang aton nga given. So we'll have 2 theta, we will have 2 theta man diri. So ang matabo mo multiply kita by 2 sa diri. So amo na siya ang reason kung nga ang aton nga answer is cosine 4 theta is equal to 0. Then 4 theta, in order to find the value of your angle theta, that will be our cosine of 0, which is 90 degrees. Then we have to find the value, mathematical manipulation. We'll have our theta is equal to 90 divided by 4. Then 2.5 degrees. Okay, so nakuha na natin ang values ng aton nga theta. Kinanglanan lang natin pangitaon is the values sang aton nga. Kaya ang value na lang sang isa naton ka angle. So ang matabo, we have cosecant squared alpha minus 1 is equal to 0. Cosecant squared. So transpose natin ng isa ka side, ang isa ka value which is 1. We have cosecant squared alpha is equal to 1, and then cosecant alpha is equal to square root of 1. Then we know nga ang cosecant by trigonometric identities, or which is a reciprocal identity of sine alpha. So we have cosecant alpha is equal to 1 over sine alpha is equal to 1. Then pwede na natin ma-convert sine alpha is equal to 1. Then trying to manipulate, mathematically, we have alpha is equal to 90 degrees. Okay, so we have to present sang another nga example sa another nga video. So this is it para sa sining introduction about advanced engineering mathematics. So watch out lang para sa next nga mga videos for the another examples. So and please review sa inyong trigonometry ng mga identities at the same time sa inyong algebra.